Hi, in this video I will show how one can conduct a multi-group analysis that is theory-driven and that is based on data that is collected from multiple groups, in this case 3 countries. So this is the model that I have, and my theory tells me that there are multi-group effects that are associated with these 2 links here, this one and this one. So the variables involved are JS, JP, OC. And the multi-group effect that I'm hypothesizing here is the effect of country, and I expect country to influence the effect of these relationships. So this is different from a full latent growth analysis. It's a latent growth analysis that is done step by step manually, and that gives access to researchers to more interesting results, as you will see. So first thing I have to do is to obtain a numeric variable that captures the countries which are here: United States, Mexico, and Brazil. So I have 3 countries, and I collected 500 rows of data, numeric data, and from these 3 countries. So I will do this in a theory-driven way. So I'll first start by creating the numeric variable based on the categorical variable. Categorical variable CO, 3 categories. So I'll create my numeric variable now using only 3 anchors, which I know they are positively correlated with one another, so I'll keep their signs as positive. And there are only these 3 here: JS, OC, and JP. So I'll include them here. And because I'm using only these 3 as anchors, and I must choose the option variation sharing here, anchor factorial with variation sharing. So since I am creating this numeric variable based on the categorical variable country, only using these 3 variables, the results here will be different than if I had included all the variables, which then would be more equivalent to just a plain multi-group analysis that is not theory-driven. And again, I'm doing the multi-group analysis here using latent growth. So I'll create my numeric variable associated with this latent growth effect. And now what I'm going to do is I'm going to go to my model, and first I will inspect the scores associated with the countries in relationship with variables here. So what I'll do is I'll delete all direct effects. I will include that country variable, now numericized. This is the indicator that was created by the software. And I'll create direct links between that variable and the other variables in the model. And this would be bivariate relationships, right? Because I have the links going from one variable to each one of the others. So there are no multiple links pointing at one variable here. Only one link from that variable, country, onto the other variables in the model. So I'll redo my analysis. And now I can see the associations between the country variable and the other variables in the model. And I can inspect the scores of the country variable and their relationships with other variables in the model. For example, with democratic management. So if I go to plot, linear and nonlinear relationships, and I choose this relationship here, and then I choose the option view relationship graphs with data points and legends, but all of the relationships are bivariate, so I can choose this. And now I will go to settings and ask the software to include that label as legends. So here I can see the scores for United States, Mexico, and Brazil. And so these are the scores. The variable has been created as standardized. So that's a native standardized variable that has been created based on the country categorical variable and its relationship with democratic management. So as we can see, there is a relationship. It's a weak relationship, but I can see that the United States is a bit more democratic than Mexico, which is a bit more democratic than the United States on average. I can do the same thing for job performance. So I'm sorry. Here for job performance. So can go there, do the same thing as I did before. And then this relationship is a bit stronger. And as we can see, job performance a bit higher in the United States than in Mexico and then in Brazil. So it's a bit higher. I can see based on that relationship with JP. These are the scores. Notice that the scores, it seems like the points are not exactly on the same vertical, and that's correct. It's because I used 3 anchor variables. If I had used only 1 anchor variable, they would all be exactly on the same vertical here. But I can have an idea of their scores, and they are for the United States 1.2, for Brazil minus 1.3, and for Mexico is around 0. So the score here for the country that was given by the software based on those anchors for the US is significantly higher than for Brazil, and for Mexico is higher than for Brazil. Now let's take a look at the latent growth effects, which are the multi-group effects, the multi-group equivalents. So to obtain those, I have to go and do something else, a third change here. So I'm going to delete the links, and I will inspect each one of the effects separately. So the first is this one. So this is the latent growth effect of the country variable on the relationship between JS and JP. I cannot include this one and also another moderating link in the same graph because that will alter these coefficients because they will compete with one another. So I have to do one at a time. So I'll do first for that JS JP link. So what I'll do is I'll include just that link. I'll redo the analysis, and I can see my latent growth effect. So it's significant, meaning country has a significant effect on this relationship, and it's a latent growth effect, like the effect of a multi-group analysis that would be uncovered by a multi-group analysis, but with a major advantage here, which is that I don't have to split my sample into 3 subsamples, analyze them, and then compare the path coefficients. I simply look at this path coefficient here, which is associated with the latent growth, and then conclude that there is a latent growth effect, there is a multi-group effect. So I can view the graph, and let's just take a look. So this is the Rocky 3D graph. So here I can see that, so this score here is for Brazil, around here for Mexico, and for the United States. So I can see that for Brazil, the relationship is kind of flat. For Mexico is steeper, and for the United States is much steeper. Okay. And I can do the same for the other latent growth effect that has been hypothesized. So I will go to my model. I will remove that direct link, and I'll create another set of two links here that will allow me to inspect that other latent growth multigroup relationship. So we do my analysis, and then I can see that graph. So it's a little stronger than the other one, 0.37, and I can inspect the graph. And I can also inspect other graphs based on this type of analysis. This one, again, here the scores down here would be for Brazil, kind of a flat relationship. For Mexico, it would be steeper, and for the United States, much steeper. So this concludes our analysis. So this is, as you can see, this is not a full latent growth. I did not use the full latent growth option in my analysis. What I did was manually I inspected each of the two hypothesized multi-group relationships using latent growth analysis that are focused on those two hypothesized relationships. So this would be a theory-driven multi-group analysis, which would be different from a plain multi-group analysis where you would not hypothesize anything. You would just analyze the subsamples separately and compare path coefficients. This theory-driven analysis would give you probably better results if your theory is correct. So it's theory dependent. So if you have strong theory, good theory, you will get better results doing this than if you do a plain multi-group analysis, which you can do using the option explore multi-group analysis. So thank you for watching.